Hi everyone. In this video I want to discuss the second law of thermodynamics, which actually relates the change in entropy of a system and the change in entropy into the surroundings and the change in entropy of the universe. And after we go over those concepts, we can try this problem. Based on the second law of thermodynamics, determine if each situation described will occur spontaneously or not, or is there not enough information to decide? The first thing I want to give you is the second law of thermodynamics. I thought I knew the second law of thermodynamics until I reviewed the textbook. I thought it was that the universe tends to go towards greater entropy. But in actuality, the second law of thermodynamics says that for a process to be spontaneous, the entropy of the universe has to increase. For a process to be spontaneous, the entropy of the universe, and that's designated delta S uni, or UNIV, has to increase, or has to be positive. Meaning that it increased. Okay, what is this delta S of the universe? Very simply, it's the surroundings and the system. Delta S universe equals the delta S of the system plus the delta S of the surroundings. And we'll put this in a box. When the process or the reaction is spontaneous and delta S of the universe is positive, you realize that these two do not cancel out. Right? They do not equal zero when you add them up. Now, if the delta S of the universe is zero, that process is at equilibrium. So there are cases where delta S universe is zero. When it equals zero, the process is in equilibrium. Literally, the process is neither spontaneous or non-spontaneous. In most cases that you'll see, the delta S of the universe will actually be a number. It is not equal to zero. But when it is equal to zero, what else does this imply? It implies that the negative delta S of the system equals the delta S of the surroundings. The magnitudes are the same, but the signs are different. But again, most times, I'll give it another bullet point so it's emphasized. Most cases, delta S of the universe is not equal to zero. It's some number. It's either positive or negative. If you think about the problems that we are going to tackle, it is our task then to figure out what's happening with the system and what's happening with the surroundings, and then decide how delta S of the universe is changing. Now, to help us with those problems, I want to go over a couple more things. In a previous video, we talked about temperature and volume and how that affects entropy. In the previous video, now this is for the system. For a system, what can be a system? A collection of gas molecules or a chemical reaction. That could be the system. For a system, if T goes up or V goes up, that means entropy has increased. If T goes up or V goes up, entropy of the system increases. If one of these is held constant. For a system, if T goes up or V goes up, entropy of the system increases, and the other variable is held constant. If, let's say 1 is held constant. Okay, so that is going to help us with the problem. Another thing that will help us with the problem is, let me give you this hint. If the system or the reaction is endo or exothermic, if the system, or you could think of it, a lot of cases, the reaction is, let's take exothermic. You want to think of how that affects the surroundings, not technically the system. So if the system gives off heat, what that means is the surroundings absorbed that heat. And therefore, it's the delta S surroundings that we can figure out if it's negative or positive. What that means is that, so the temperature of the surroundings went up because of this. Because of that. That means now, from the surroundings point of view, its entropy goes up. So it will be positive. We're going to see in just a second that they're going to talk about endothermic and exothermic chemical changes. We want to be able to say something about the surroundings when that happens. Is the surroundings absorbing that heat, or is the surroundings giving up that heat? That's how we're going to figure out the plus or minus for the surroundings. I think that's it. Why don't we go to the problems? I will do the first, or if you feel like you understand these 4 bullet points well, then go ahead and pause the video and try these 3 situations and tell me whether this is spontaneous or non-spontaneous. Okay, those are the 3 situations. Let me take the first, or you could pause the video right now. Okay, a gas contracts and at the same time absorbs heat from its surroundings. Okie dokie. What this tells me is when the gas contracts, that means the volume goes down for the system. And that means that the delta S of the system is negative. It lost entropy. But at the same time, it absorbs heat from its surroundings. What that means to me is that the surroundings temperature goes down, and therefore the delta S of the surroundings is negative as well. Negative as well. And if you recall the equation, delta S universe equals delta S system plus delta S surroundings. We have a negative. We have a negative. This has to be a negative. So this is a negative, and our conclusion is that this process is non-spontaneous. Do you see how that works? Don't get, I think I got hung up, and I think some students will get hung up with this idea that the system is absorbing the heat. True, the system is gaining in temperature, but the volume is going down, so there's a conflict there. One says negative and one says positive. So for the delta S. So you want to take that idea that the system is absorbing heat and think about it from the surroundings point of view. That's how I want to do these problems. Want to try this one? B. A chemical reaction between two liquids creates gaseous products. Well, okay, we have a chemical system that you have two liquids. Liquid 1 plus liquid 2 goes to gas, gaseous products. What that means is that you're creating gas, so gas has more disorder than liquid. For the system, delta S of the system, that should be positive. It gained disorder. Now, there's actually nothing we can say about the surroundings, according to this sentence here. So we don't know what's going on with the surroundings. There's no conclusion we can make. Therefore, if you have, again, your equation, delta S universe equals delta S system plus delta S surroundings. We have a plus here, but we have a question mark here. We don't know if the delta S of the universe is positive or negative. Therefore, we need more information. Therefore, we need more info. So far we have non-spontaneous, and here we need more info. Last one. During an exothermic chemical reaction, 2 moles of gaseous reactants are turned into 3 moles of gas. 2 moles of gaseous reactants goes to 3 moles of gaseous product. We gain in the number of gas molecules, but everything else being kept constant. We definitely have more disorder. The more gas molecules you have, the more disorder. Therefore, the delta S of the system is positive. The reaction, though, is exothermic. Again, I know that this is talking about the system. We want to use that information and describe what's happening to the surroundings. And because of this, that means the surroundings is gaining, it's absorbing that heat. And therefore its temperature goes up. And if the surroundings, the temperature goes up, then the surroundings entropy goes up. Therefore, delta S of the surroundings is positive. So again, we have delta S of the system. Oops. Delta S of the system and delta S of the surroundings. System is positive, and the surroundings is positive. This is the one case where now the process is spontaneous. We actually have one of each. We have a non-spontaneous process, a process where we need more information, and letter C, the process is spontaneous.